Hello everyone, I want to use this video to go over lecture number 7, Global Climate. So the reading chapter is either of the two books we used in our class, can be chapter number 12 in Essentials of Meteorology or Meteorology Today, chapter number 17. Okay, so here are the key things you want to focus on and you want to answer the questions I listed there on our discussion page. Let me show you. Here we go. Okay, to summarize those questions in your initial post. Okay, so here, the number one is, what's the difference between weather and climate? Okay, so what's the difference? Well, actually very simple. Weather is a state of atmosphere at any given moment. So we are talking about second, minute, or the longest will maybe hour. Okay, but climate is a long-term average of weather and the average frequency of extreme weather events. So we are talking about years. We're talking about average temperature, precipitation, wind, humidity represent the climate of a given region. Okay, so if you need to draw the conclusion, describe the climate characteristics of one region, you need to collect the data for more than 30 years. Okay, so here that is from our textbook, the sample statement. Okay, about what people talking about the climate phenomena and the time scale. Okay, weather and climate, the phenomena and the time scale, as you can see here. Okay, all right. So in the previous slide, here we go. We talk about the tempo scale or time scale, but climate also have another scale called spatial scale. So we are talking about the climate in a smaller area or a larger area. So for example, a microclimate can be climate very in near ground in a very small zone, like a park, like an airport. Okay, or mesoscale, or climate of a small area of Earth's surface, for example, in a forest at the Santa Monica Beach, right, San Fernando Valley. Okay, or macro climate of a bigger region like a state or small nation. Okay, global scale. Okay, planet scale. Okay, so be aware of what kind of scale you're talking about. You will describe the climate in different ways. Okay, so global scale or macro or meso scale, we usually use climograph to visualize the characteristics of one region. There's two things we're especially interested in to describe when we describe the climate characteristics in one region. One is precipitation. Okay, we use bars on those graphs. The other one is temperature. We usually use the curve, okay, of that region to represent temperature of that region. Okay, so as you can see here, this is the climograph of Los Angeles. Well, very obviously, you can draw the conclusion, right? In the summer, when we have very hot temperature, we have very little precipitation in LA. So you will draw the conclusion of Los Angeles, the climate. We have hot and dry summer, but cool and moist winter. Right? So that is the climograph that is very useful when you describe the climate characteristics of one region. Okay, so you can see we are talking about the temperature, precipitation, and how temperature and precipitation change in a year, aka seasonal variation pattern. So from winter to summer to winter, okay, how temperature change, how precipitation change. That is called seasonal pattern. Okay, so based on that, we actually can classify the climate types. Okay, put your climate type in one of those categories. Okay, so that is the Köppen climate classification system. Okay, so here this is actually a very important thing in this chapter. So make sure you read the chapters, okay, one of the two books, to study the specific characteristics of each type. Okay, so here, because you have a lot of information there, and most of them actually you need to memorize it. Okay, so here I won't spend too much time to describe the characteristics of each region, each type, but I do want to give you that overview how Köppen developed this classification system. Okay, so you can see this is actually three layers or three tiers classification. So first, based on temperature, Köppen classified the global climate into 1, 2, 3, 4, actually 4 types. Okay, and based on moisture, we have a special climate type called dry. Okay, and we have another special group that is the climate is mainly affected by elevation. We are talking about the highland, like Peru, Cusco, okay, like Himalaya mountains, okay, that is a highland climate. So A, C, D, E is purely on temperature. Okay, so you can see from tropical to mild climate, mild mid-latitude, that is minimum, the lowest temperature is still above 0 degrees Celsius or 32 Fahrenheit, versus the severe mid-latitude, that is the coldest month is lower than freezing point, okay, 0 degrees Celsius or 32 Fahrenheit, and polar, extremely cold. Okay, and based on that, the first letter you should put it as uppercase. The second letter basically is about precipitation. Okay, so you can see here we have F, means all year long you have very moist months. So we're talking about precipitation, seasonal change. Okay, monsoon, that is, we learned monsoon, right? The moist climate. Okay, is very moist, okay, versus a very dry season. So that is the when the wind shifts, okay, over the continent, you have different moist climate, moist season, and versus dry season. W is mainly just dry in winter and wet in summer. Okay, but for the mild mid-latitude or severe mid-latitude, we have this S. S is dry season in the summer. That is LA. We're CS climate. Okay, we're CSA or CSB climate. Okay, or some people, when they collect data in different regions, we also classify LA, Southern California as dry. Okay, different region like Mojave, that is dry region. Okay, and you can see W and F, they're same. Okay, but for polar, you need to put uppercase T and F. ET means the warmest months between 10 degree and 0. Okay, and it's basically is taiga, okay, tundra, this climate. You still have trees, but EF is extremely cold. Okay, its warmest months still below 32, so you don't have trees, you don't have vegetation. Okay, and dry climate is easy. You still need to put it uppercase. Okay, semi-arid or totally arid. Okay, and then for this mild climate, mid-latitude and severe mild latitude, after this second tier, you have the third tier. Okay, A, B, C, D, purely on temperature. Okay, for this for this dry climate, you also have the third tier. Okay, means it's B, its mean annual temperature is greater than this. It's very hot, or you have some like cooler air, okay, down there. So you can see 3 tiers. Use 3 letters to describe temperature and precipitation. Okay, so read your textbook to learn the characteristics of each type and the typical landscapes you would expect in each type. Okay, all right, so this basically is global distribution of this Köppen climate classification. system, different climate, where they, so you can see A, tropical, right? It's basically here, but B, you can see here, it's mainly at 30 degrees, subtropical, right? Okay, you can see B here, very predominant. Well, why? Right? Because subtropical high, right? In our wind system, pressure zones, we know 30 degree, around 30 degree, we have that high pressure zones, subtropical high, air constantly descending, right? So that is why you have dry climate along this line. Okay, that is dry climate. Okay, another region you have dry climate is those region inland. Okay, very far away from ocean, like here. Okay, in the middle of Eurasian continent, right? Okay, right here, or let's see, Arizona, right? Or Sahara. Sahara have double dry. Okay, so that is the distribution. So study this type, these maps, you maybe wonder what kind of controlling factors, right, can control the can cause certain area have certain climate, right? Very good point, very good question. So this is basically in US, which type of climate type is where. Okay, so then we want to study another emphasis in this chapter is climate controls. Okay, so what are the factors control climate? Okay, so number one is the sunshine, solar energy you get. Well, we are lower latitude, right? Okay, we are very close to equator, means you will have a lot of sunshine. That is why Los Angeles is fairly warm, right? And distribution of land and water, we're talking about land and water heating difference. So land, in fact, actually can absorb the heat. Temperature can rise over land very, very quickly. Okay, but water and drop down very quickly. But water can maintain the heat very well. So if a region close to water, you will see the temperature won't change that much, like Santa Monica versus San Fernando Valley. Valley temperature, day temperature, and night temperature actually change a lot, right? Okay, so that is one thing. Ocean currents can also affect the temperature. So for example, here down LA, even we have very hot summer, but not as hot at the other side of Pacific. Okay, if you have people from Japan, okay, you from China, East Coast, the coastal area, you know that area on the west side of Pacific, right? The summer temperature can be very high. Why? Because you have that Japan currents, which is a warm ocean currents. Okay, let me show you. Okay, here you can see Kuroshino currents. This is the warm currents, but our California currents is a cool currents. Okay, so that can cool down our summer temperature. Okay, so ocean currents is another factor. Prevailing winds. Okay, well, the wind constantly blow from certain direction can give you different precipitation, right? So for example, let's see, the wind, for example, let's see, Hawaii. Okay, let me use this. Here we go. For example, our Hawaii where? Right here, right? So you can see you have a high pressure here. Hawaii in Hilo, for example, you constantly have this trade wind, right, blowing into Hilo, and then when those wind rises against the mountain volcanoes, Hilo is very, very moist because those wind bring a lot of moisture from our ocean, right? Okay, so you can see wind also have a very important impact on our climate. Okay, and positions of high-low pressure area, I talked about it already. So you can see we have a high pressure here, we have high pressure here, so that is why along this line, right, you have dry climate. You have dry climate. Okay, and there's one thing very interesting. Let me show you here. Okay, those high and low pressure center, they don't just stay in one location. They actually shift with seasons, with your 90-degree sun. So for example, now 30-degree, maybe here, right, is controlled by this high, subtropical high. We have dry season, but you can see our CSB, why LA, we have that dry summer, right? Well, that is in the summer. This subtropical high will move into the north because your 90-degree sun moving to the north, right? So in the summer, we actually controlled by this subtropical high that give us the dry summer. But why we have the wet winter? Because this polar front, rising air, in the winter they're moving down. Okay, they will give us a lot of rain in the winter. Okay, so let me show you here. So you can see that's right here. That is located in Alaska. In the winter, they will moving down, moving to the south. Okay, to bring a lot of stormy weather to LA. Okay, so that is one reason. That is the one reason. Okay, of LA's climate. Okay, and then you can see mountain barriers. Of course, I talk about Hawaii, and you also see San Fernando Valley versus Malibu versus Santa Monica, right? And LA versus Vegas. You have that rain shadow. Recall what we learned in our wind chapter. Okay, and of course, altitude. The higher you go, the cooler you have, right? The cooler you are. So you can see those 7 climate controls is very important. So again, a lot of details on your textbook. Read this page. This should be in Meteorology Today, that page. Okay, so here, latitudes, low latitudes, you have more sunshine. Okay, I go over that already. And higher latitude, you have a lower sunshine. Okay, altitude, the higher you go, the cooler you are, right? Okay, and rain shadow. Okay, we talked about it already. And water body. For example, San Fernando Valley, Pasadena, you have very dramatic change. Okay, or versus Santa Monica, the temperature is fairly stable, right? Okay, ocean currents, I talk about it. As long as you're close to a cold current, your temperature can be quite stable, quite cool, but warm currents will give you more moisture, will give you a hot temperature. Okay, and our high-low pressure. Okay, well, if you are controlled by high, you are dry. Controlled by low, you are moist. But don't forget, they're shift. Okay, so that will give you those seasonal wet and dry. Seasonal wet and dry. Okay. All right, I believe that is everything you want to study in this chapter, in this lecture. Focus on the question I posted on the discussion board and also the study guide questions. Okay, in the study guide question, on the study guide page, you also have a lot of videos. These are weather log. You also have a lot of I think I should go back. That is the second page of this module. Right here. It's climate classification, climate. Okay, here we go. You will also have a lot of videos. Make sure you watch those videos when you study this chapter. Okay? Alright, have fun. Enjoy learning. I will see you in our class, the office hours and online. Bye for now.